The crank sensor lets the ECM know the engine's rotational speed and crankshaft position. There are three main types of crank position sensors: the magnetic, Hall effect, and magnetoresistive sensors. The last two work the same way. The magnetic sensor generates its own signal. It is composed of an internal coil that captures the magnetic field from the reluctor and has two wires. One wire is the sensor ground, and the other is the signal wire itself. To test these sensors, connect an oscilloscope or graphing multimeter, such as the ATP Scope 1 Pro. Crank the engine and look for a sine or rounded waveform. A minimum of 2 volts peak-to-peak is needed for the signal to get recognized by the module. The Hall effect and magnetoresistive sensor has 3 wires and an internal transistor. The sensor ground, the 12-volt reference, and the signal wire, which is usually a 5, 7, or 8-volt reference. It is the job of the 3-wire Hall effect sensor to toggle or bring this 5-volt reference voltage to ground as the engine turns. A long reluctor tooth, seen in red, is used to denote cylinder number 1 position. Perform all Hall effect sensor tests with key on, engine off. To test the Hall effect sensor, connect a test light to battery positive. Then, probe at the sensor ECM provided ground. You should see a bright light. Change the test light to battery ground, and probe at the sensor's 12-volt reference wire. Again, the test light should be lit. Finally, to test the signal circuit, do not use a test light. Use a multimeter or oscilloscope. Connect to the sensor's signal wire. With key on, engine off, should see reference voltage, usually 5 volts. Then, crank the engine and look for a square wave at the scope screen or a changing DC voltage. Magnetic sensors produce a sine wave. Hall effect sensors produce a square wave. A trick to use on a non-running engine is to connect a test light to battery ground. Turn the key on, disconnect the crank sensor, and momentarily touch the signal wire, on and off. This should trigger the ignition module, or ECM, into producing a spark, which you can see or hear. A final trick to use is to grab a soldering gun, put the back part close to the sensor, and press the trigger. The huge expanding magnetic field from the soldering gun will make the ignition module create a spark at the sensor itself. If no spark, then the sensor may be defective. These are quick tests, and in no way are meant to abolish the normal manual tests mentioned here. Just use them as a possible guide to the repairs.